China is building robots so massive and so powerful that they look less like machines and more like mechanical giants stepping out of the future. These are robots that lift more than cranes, sprint like athletes, survive nuclear radiation, and perform tasks no human could ever attempt. Some move with the precision of surgeons, some hit with the force of industrial machinery, and one of them is so enormous it can lift 60 tons with millimeter accuracy. So today, we're diving into the 8 biggest robots China has ever created, and once you see what China built at number 1, you'll understand why the world is paying attention. Number 8. Kuafu, humanoid robot. We begin with a robot that doesn't just walk, it performs on the world stage. Kuafu, named after the legendary giant who chased the sun, is China's first 5G-enabled humanoid robot built by Leju Robotics in collaboration with China Mobile and top national research institutes. Standing at 166 centimeters and engineered for dynamic locomotion, Kuafu shocked the world when it became the first robot in history to carry an Olympic-style torch, running 100 meters with lifelike posture, arm swing, and balance control. Its motion control system calculates adjustments in real time, while its advanced load balancing algorithms allow Kuafu to sprint, pivot, and stabilize without human intervention. The robot's 5G connectivity gives it ultra-low latency perception, allowing cloud-based AI models to guide movement with millisecond precision. This is not just a humanoid robot, it is a public symbol of China's AI-powered future, demonstrating to the world that robots can perform ceremonial, athletic, and social tasks with extraordinary realism. Well, Kuafu may not be the tallest or the strongest, but it is the robot that proved machines can move with purpose, emotion, and spectacle. But if Kuafu represents symbolic power, then our next robot focuses on pure mechanical performance, a lightweight humanoid built for agility and speed. Number 7. Unitree H1 humanoid. The Unitree H1 is what happens when engineers decide to strip a humanoid robot down to its essentials and rebuild it for pure speed and agility. Standing 1.8 meters tall but weighing only 47 kilograms, the H1 is one of the lightest full-sized humanoids in the world, a mechanical sprinter designed to move with explosive momentum. Its simplified structure houses powerful actuators capable of delivering up to 360 Newton-meters of torque at the knee and 220 Newton-meters at the hip, giving the H1 a running capability that surpasses many of its heavier rivals. This robot can move at speeds over 3.3 meters per second, maintaining stability even during rapid acceleration, sharp turns, and sudden stops. Despite its lightweight design, it still carries up to 10 kilograms and can be expanded from 4 degrees of freedom in the arms to a more dexterous 7DOF configuration. The H1 is used heavily in research labs, robotics institutes, and industrial testing environments, not for brute strength, but for mastering human-like locomotion at high speed. It is the robot built for movement first, everything else second. A fast, flexible runner, a test platform for future robotic athletes. And now, our next robot is the Performer, a humanoid known for dexterity so refined that it can cook, play instruments, and move with near-human precision. Number 6. Astribot S1 humanoid. Imagine a robot so precise it can crack an egg, assemble intricate components, and play a piano melody, all with the same pair of hands. That is the Astrobot S1, one of China's most impressive demonstrations of robotic dexterity. Standing around 165 to 170 centimeters and weighing roughly 80 kilograms, the S1 wasn't designed to overpower humans. It was designed to match our finesse. With 36 degrees of freedom and highly articulated 7DOF arms, it moves with a natural, almost artistic flow. Its defining feature is its astonishing 0.03 millimeters repeatability, a level of precision that allows it to perform tasks normally requiring expert craftsmanship. Cooking, folding clothes, polishing surfaces, operating tools, pouring liquids, even performing synchronized tasks. The S1 executes each action with calm accuracy. Despite being built for fine control, the S1 still delivers real strength, carrying up to 10 kilograms per arm. Its top movement speed of 10 meters per second gives it fluid, confident motion that feels more like watching a trained operator than a machine. The Astrobot S1 is not just a robot worker, it is a robot artisan, blending precision, creativity, and control in a single frame. And while the S1 excels in delicate mastery, our next robot focuses on something entirely different: raw, high-speed humanoid mobility. Number 5. Unitry Alieno. The moment the Walker S1 steps forward, you immediately notice something unusual: a robot moving with the calm confidence of a trained professional. UBTech designed this humanoid not as a lab experiment, but as a workforce machine, built for factories, warehouses, and large-scale automation. Standing roughly 172 centimeters tall and weighing 70 to 76 kilograms, the Walker S1 incorporates 41 degrees of freedom, giving its motion system smooth, natural articulation. Its control architecture blends physics-based modeling with learning-driven locomotion, allowing it to adjust its balance and gait dynamically. Whether it's walking at 1.5 meters per second, climbing ramps, navigating tight industrial aisles, or performing repetitive tasks, the S1 maintains stable, reliable movement. Its actuators are engineered for high torque and fast response, enabling precise handling of tools, components, and machinery. Meanwhile, its modular hardware and software design lets companies reconfigure the robot for assembly lines, inspection routines, customer service roles, or collaborative environments where humans and robots work side by side. The Walker S1 isn't built to entertain, it's built to work, day after day, in environments where consistency matters more than flair. But speed and stability are only the beginning, because the next robot takes humanoid performance into the realm of towering height and heavy-duty capability. Number 4. KingLong V3.0 Humanoid. Some humanoid robots are designed behind closed doors. QingLong V3.0 is not one of them. This towering 185 centimeters, 85 kilograms machine is one of China's most advanced open-source humanoids, built to accelerate innovation by letting engineers, universities, and companies study, modify, and reinvent its entire architecture. With 43 active degrees of freedom, QingLong moves with a combination of strength and technical refinement. Its joints deliver up to 400 Newton meters of peak torque, giving the robot the muscle needed for lifting, climbing, tool operation, and heavy-duty manipulation. Yet its real power comes from its brain, a staggering 400 TOPS of onboard compute, enabling real-time perception, balance, and motion planning. QingLong walks at around 1 meter per second with exceptional stability, even on slopes or uneven terrain. Its modular structure allows quick swaps of arms, hands, or leg configurations, letting teams adapt the robot for research, manufacturing, public service, or advanced field testing. This is the humanoid built not just to perform, but to evolve, as thousands of developers shape its future capabilities. And if QingLong represents open development at scale, the next robot pushes the boundaries of raw power, a machine engineered for explosive movement and extreme athletic performance. Number 3. EngineAI T800 Humanoid. The T800 doesn't just look powerful, it is powerful. Standing 1.73 meters tall and weighing 75 kilograms, this humanoid robot is engineered for extreme dynamic performance, built to handle movements that most robots can't even attempt. With 43 degrees of freedom, including sophisticated, fully articulated hands, the T800 moves with a combination of raw torque and precise control. Its joints deliver up to 450 Newton meters of peak torque, making it one of the strongest humanoids in its class. That strength translates into explosive athletic ability, flying kicks, capoeira spins, martial arts movements, aerial rotations, and fast, stable recovery. Even after sudden impacts, the robot's designers didn't just aim for balance, they aimed for agility under stress. Powering the T800 is a modular solid-state lithium battery system, giving it 2 to 4 hours of endurance, enough for extended training, industrial testing, or continuous dynamic demonstrations. Its sensing and control algorithms allow it to adapt mid-movement, maintain posture in unpredictable environments, and execute high-speed maneuvers without losing stability. The T800 is not a gentle service robot, it's a performance machine, built to push humanoid motion to its physical limits. And while the T800 dominates extreme movement, the next robot rises even higher, literally, with a taller frame, heavier build, and broad general-purpose capabilities. Number 2. Unitree H2 Humanoid Robot. So there are robots built for experiments, and then there are robots built to rewrite the standards. The Unitree H2 belongs firmly in the second category. Standing 180 centimeters tall and weighing 70 kilograms, the H2 is a full-sized humanoid engineered for high-performance locomotion, expressive movement, and industrial versatility. Unlike many humanoids that struggle with balance or power delivery, the H2 is built around 31 degrees of freedom and a cutting-edge torque system that delivers exceptional force where it matters most, the legs and hips. Its peak joint torque reaches an impressive 360 Newton meters in the legs and 120 Newton meters in the arms, giving the H2 the ability to lift, carry, and stabilize heavy loads far more efficiently than earlier generations. But the H2 isn't just strong, it's incredibly coordinated. Using advanced balance algorithms, it performs dynamic motions such as ballet spins, kung fu routines, rapid turns, and low-to-high posture transitions with surprising elegance. The robot's AI control stack allows it to adapt to uneven ground, slopes, and sudden impacts without losing composure. This gives the H2 practical value across industrial environments, service roles, logistics, and even human interactive spaces. A 7-kilogram normal payload, expandable to 21 kilograms at peak capacity, makes it capable of real, physical work. Meanwhile, its lightweight carbon fiber structure keeps its movements efficient and energy usage low. Whether lifting objects, demonstrating martial arts, or navigating busy environments, the H2 blends athletic power, fluid motion, and robotic precision into a single, strikingly capable platform. Among China's humanoids, the H2 represents the new benchmark. Not just a walker, not just a lifter, but a true robotic athlete ready for mainstream deployment. So, if the H2 is the athlete, then our final robot is the giant. A machine so massive, so powerful, and so precise that it's redefining what biggest robot in China truly means. Number 1. Craft Nuclear Fusion Robot. This is the Titan Extrema of robots, and it's because this robot is different. It's defined by pure, overwhelming physical power. The Craft Nuclear Fusion Robot is the largest, strongest, and most precise mega robot China has ever built. Designed for the Comprehensive Research Facility for Fusion Technology at the Chinese Academy of Sciences, this system isn't just doing factory tasks or warehouse movements. It's built to operate in the heart of a nuclear fusion reactor, one of the harshest environments on Earth. At its core is a massive triple-armed robotic system. Its primary manipulator alone can lift 60 tons, the weight of 10 African elephants, with extraordinary stability. Yet despite this monstrous strength, it achieves vertical positioning accuracy within 4 millimeters, something no other fusion-handling robot has matched. The two auxiliary robotic arms deliver even greater finesse, achieving plus or minus 0.01 millimeter repeatability, allowing them to position components with surgical-level precision. This combination of brute force and microscopic accuracy makes the system a world-class engineering breakthrough, surpassing the payload and precision capabilities of every existing robot in the nuclear power industry. Fusion reactors demand remote systems that can tolerate radiation, extreme heat, and long periods of autonomous operation. The Craft robot was engineered precisely for this reality, to assemble, maintain, and manipulate parts inside environments too dangerous for any human being to enter. It isn't just a robot. It's a colossal mechanical guardian standing at the edge of humanity's most ambitious energy experiment. And in a world where humanoids run, jump, balance, and perform delicate tasks, this machine reminds us of something important. Sometimes the biggest robot isn't the most human, but the one that does the jobs humans will never be able to do. And after witnessing all 8 of these giants, which of these robotic titans would you trust to shape the future of humanity? From humanoids that move with athletic grace to machines that can lift more than entire buildings, China is constructing the next generation of mechanical life. But are we stepping into an era where machines grow stronger, smarter, and more capable than anything we've imagined, in ways we may not be fully prepared to face? Let me know in the comments. The future is being built right now. The debate starts here.